Welcome to the next section of Chapter 8, dealing with the brain and the spinal cord. So let's first look at the different layers that we have within the brain. And we're going to look at it in different ways. As you can see, and then we'll look at a live version, as we talked about in class, the brain has several layers to help protect it. Yes, it has the outer layer that you can see here within the skull, but there are also several very thick and tough layers of material that allow the brain to be supported. This is very important as we get down the line to start talking about concussions. The first layer that we'll talk about is the dura mater, right here. Dura meaning tough, mater meaning mother. This is a very, very thick outer layer that is very clear, clear and cloudy in color. We will look in our next slide actually at a live video of what this looks like, and the dura mater, as we spoke of in class, it's like a giant, as you can see here, almost this layer right in here, it's almost like a giant ziplock that kind of encloses the skull and the brain. This is kind of the first layer of defense between the brain and the skull. The next layer that we will see far as here is the dura mater outer layer. Then obviously there's a little layer of fluid, and then the inner layer, or the inside of the bag, what happens is that lays against a very small space. This is called the subdural space or subarachnoid space, because this right here, this area that's kind of between the dura mater and your brain, this is the arachnoid space, and you have tiny fibers, all right, within this that connect from the dura mater down to the brain. It almost acts like if you are, for our athletes that are within contact sports, if you look at the new material within your helmets, whether it be football, lacrosse, even baseball helmets, even now what we're having in skiing, snowboarding, motocross, even down to even some of your mountain bike helmets, even your regular helmets now, have this kind of compressed honeycomb fashion type material. This allows for a great amount of force to be put on the material, but it doesn't disperse. It allows for the material to be obtained a lot of weight, but then what happens is it doesn't squish down. It doesn't compress. So when you have that, it does allow some protection. But right along here, as you can see here, this is our brain tissue. You also have another fine layer called the pia mater, or very small, thin mother. And this is the final line of defense right in before we get to our cerebral cortex or to our delicate brain tissue. We're now going to go and look at a video, a live cadaver video of removing the skull and looking at the dura mater and pia mater. I will caution you, this is a live cadaver section, so please be advised, and be ready to stop if this does bother you. We are on YouTube, and we will begin looking at this cross section. Here is the skull, as you can see, that's being prepared, and so let's move forward so as we can see the different layers. Like I said, I will caution you, this is live specimen, not a live specimen. This is a cadaver that's been has not been embalmed, and so we'll be able to see the material that would look very similar to what you would see if you removed anyone's skull. So now as the scientist begins to remove the skull, right, as I said before, you can start to see gravity has taken over. This has not been embalmed. There's been no fluid within this specimen, within this body, so the brain has started to settle. Now you can see the scientist is pointing to the dura mater that's right along the midline of the brain, right in here, and you can see how it's, like I said, it's very tough material, very thick material, and you'll see how he will start to move the material laterally so you can see the difference in layers. So as he begins with his forceps with the scissors and the scalpel, you can start to see how the underlying layer, all right, here's the underlying layer of the dura mater, here's the outer layer, here's the underlying layer. You can kind of see how it's pulling along these different fibers, right? Right in there, you pull along those different fibers of that, of that space, and as they move this laterally, you can start to see those vessels, those cranial vessels that provide a lot of the blood supply to the brain. And you can see how it's very, very thick. Like I said, this is just as thick as shopping bag or just as thick as any type of Ziploc bag. And this is very important because, as we will discuss, it's your first line of defense once you come through the cranium. And as you can see now, they're zooming in so you can start to see the different vessels of our right hemisphere, and obviously getting down so you can start to see the pia mater as they fold that back. But the bottom line is these two structures, the dura mater and pia mater, are the last line of defense for the brain. We talked about in class the blood-brain barrier. We will be talking further about concussions. This is very important. These materials and what goes through or what cannot go through these areas are vital, especially to particular disorders and or when we're dealing with concussions, as you can see. So once again, to recap, they have done a midline incision. They have removed the pia mater, and so we can start to see that dura mater space. Here is what the underlying part of the skull looks like as they removed. Here's the inner lining of the cranium, and you can see the smooth area where that tough outer layer of the dura mater would lie against the skull, and the underlying layer of the dura mater is going to lie against the brain. And you can see as the scientist, the doctor, is pointing out into the different plates, the different fissures, as our brain develops, how those plates will form around our brain to help protect it. You can see here's the occipital lobe, here's the frontal lobe. We're looking at our temporal lobes. All right, here's the left, here's the right, and also you can see how thick this is in the frontal region versus the occipital region as well, to kind of give the skull its proper full screen as we move forward in the lesson, the different layers as we remembered. And as you can see, here's just basically the anatomical definition, of the dura mater, pia mater, okay, and the arachnoid space. The pia mater, as you can see, that's the innermost layer that lies right along your cerebral tissue, right along the neuro tissue of the brain, and it is connected. It is bound to the underlying neural tissue. You cannot remove the pia mater as easy as the dura mater, and we will notice this as well when we get into our fetal pig dissection. And so, one thing that I would like to do as we move forward for this evening, your homework for this evening, I really would like for us to start doing some research in and around dealing with concussions. If we can do that this evening, that would be great. So I will put on the portal if we can. If you can research, I would like to see any type of scientific research dealing with concussions, and so we can be able to start to look at that and see how this has an effect on the central nervous system. In particular, I'd like to see if you can find anything, concussions and with the dura mater and within the pia mater. Okay, and so once again, so excuse my scratching here. Once again, if we can find something to deal with concussions and how it affects within the dura mater or pia mater, that would be fantastic. And if you can be able to describe with any information that you might have about how this would affect. How did the concussion occur? What kind of concussion is it? How did it happen? And if you can find any type of information on the damage that may occur to the dura mater or pia mater, and how does it heal? I really would like to talk about that, in our next class, to really see how we can move forward. And so once again, to recap, we looked over the dura mater, the pia mater, and the different layers. And so let's move forward tomorrow, and I'd like to start a discussion in and around concussions. Thank you, and that's the end of